Imagine soaring through the sky, not with the roar of jets, but with silent electric power. Step inside the revolutionary factory where this dream is becoming reality, transforming visionary blueprints into next-gen aircraft that will redefine how we travel. This is where the future of flight is being built, piece by intricate piece. Today, we're getting an exclusive look behind these doors to witness the birth of electric aviation. For over a century, the sound of flight has been defined by the roar of combustion engines. It's been a symbol of power, progress, and human ingenuity. But what if the future of flight sounds like almost nothing at all? What if it's cleaner, more efficient, and powered entirely by electricity? That's not a far-off dream. It's happening right here, right now. Welcome to the heart of the electric aviation revolution. This isn't just any factory. It's a cathedral of innovation where bits and bytes, carbon fiber, and a whole lot of brainpower come together to create the airplanes of tomorrow. Let's start where every great idea begins, the design phase. Here, in what they call the digital twin department, the aircraft exists entirely as a computer model long before a single physical part is made. Engineers run thousands of simulations, testing everything from aerodynamic performance to the structural integrity of the wing spars. Every wire, every circuit, and every screw is meticulously placed and accounted for in this virtual world. This digital precision minimizes errors and waste, making the entire manufacturing process incredibly efficient. They can simulate stress from turbulence, the flow of air over the wings, and even how the battery systems will perform under different temperature conditions. It's a ballet of data, and it's the foundation for everything that comes next. Once the design is perfected digitally, we move from the virtual to the physical. And the first thing you'll notice is the material. Forget the traditional aluminum you see on most commercial jets. Here, it's all about composites. We're talking about vast sheets of carbon fiber fabric, light as a feather, but stronger than steel. Robots, guided by lasers, precisely cut these sheets into complex shapes. Then, skilled technicians layer them by hand into molds, a process that feels more like artistry than manufacturing. Each layer is oriented in a specific direction to provide maximum strength where it's needed most. It's this lightweight, ultra-strong material that is key to making electric flight possible, as every single ounce saved means more range and efficiency. After the layers are in place, the molds are vacuum-sealed and moved into giant ovens called autoclaves. Inside, under immense heat and pressure, the resin-infused carbon fiber cures and hardens into a single, solid piece. What emerges hours later is a perfectly formed fuselage section or a sleek, aerodynamic wing. The surface is so smooth you can see your reflection in it. The precision here is mind-boggling. We're talking about tolerances measured in fractions of a millimeter. Every component must fit together perfectly, like a giant, high-tech puzzle. Now for the heart of the aircraft, the propulsion system. This is where the real magic happens. Instead of a single, massive jet engine, these aircraft often use a distributed electric propulsion system. That means multiple smaller, highly efficient electric motors are placed strategically across the wings. Look at this motor right here. It's incredibly compact. You could almost hold it in your hands, yet it generates a surprising amount of thrust. And because they're electric, they're whisper quiet and produce zero operational emissions. The assembly of these motors and their propellers is a task of extreme precision. Engineers work in a clean room environment to put together the intricate windings and magnets that make these motors spin. Each one is tested rigorously, its performance monitored and recorded to ensure it meets the exact specifications laid out in the digital design. The propellers themselves are also works of art, sculpted from composite materials for optimal aerodynamic efficiency and minimal noise. It's the combination of these advanced motors and propellers that gives these electric aircraft their unique, almost silent, flight characteristics. Of course, you can't have electric motors without a power source. And that brings us to the biggest challenge and the biggest area of innovation in electric aviation, the batteries. These are not your average AA batteries. We're talking about massive, custom-designed battery packs that form an integral part of the aircraft structure. Here, technicians are carefully assembling thousands of individual battery cells into modules. Each cell is monitored by a sophisticated battery management system that ensures optimal performance, safety, and longevity. The thermal management is crucial. Keeping the batteries cool during high-power takeoff and charging is a major engineering feat. You can see the intricate network of cooling channels and sensors built into every pack. The energy density of these batteries, How much power they can store for their weight is the single most important factor determining the aircraft's range. And the technology is improving every single year. Now, let's head over to the final assembly line. This is where all the individual components we've seen, the fuselage, the wings, the motors, the batteries, finally come together. It's a surprisingly quiet and clean environment compared to a traditional aircraft factory. There's no deafening sound of riveting guns. Instead, you see teams of engineers and technicians carefully bonding and fastening these large composite structures together. Giant robotic arms assist in lifting and positioning the heavy wings into place with millimeter accuracy. Next comes the intricate process of wiring the aircraft. They call it the nervous system. Miles and miles of wiring connect the flight controls, the sensors, the motors, and the battery management system to the central flight computers. Every connection is checked and double-checked. This isn't just about making the plane fly. It's about building in layers of redundancy and safety. In an electric aircraft, the software is just as important as the hardware. The fly-by-wire system translates the pilot's inputs into precise adjustments of the motors and control surfaces, constantly optimizing for efficiency and stability. Once the aircraft is fully assembled, it undergoes a rigorous series of ground tests. Every system is powered up and checked. The landing gear is retracted and deployed. The control surfaces are moved through their full range of motion, and the motors are spun up for the first time. Engineers monitor a dizzying array of data points, ensuring that everything performs exactly as it did in the digital twin simulations. These tests can take weeks, as every scenario, from a normal flight to potential emergency situations, is simulated on the ground. And then comes the moment everyone has been working towards: the first flight. The aircraft is rolled out of the factory and onto the runway. It's a culmination of years of design, engineering, and manufacturing. As it accelerates down the runway, the most striking thing is the sound or the lack of it. There's no roar, just a gentle hum as it lifts gracefully into the air. It's a surreal and powerful moment, a glimpse into a cleaner, quieter future for aviation. What we've witnessed here today is more than just the building of an airplane. It's the creation of a new paradigm. These electric aircraft promise to open up new possibilities for travel, connecting smaller communities with short-haul flights that are both environmentally friendly and economically viable. They represent a fundamental shift in how we think about flying. The journey from a digital blueprint to a silent wing soaring through the sky is a testament to human ingenuity and a powerful symbol of hope for a more sustainable future. The revolution is happening, and it's taking flight right here. Thanks for joining us on this incredible tour. If you're as excited about the future of technology and aviation as I am, make sure to hit that subscribe button and ring the bell so you don't miss our next adventure. Let us know in the comments what you think about electric flight. Until next time, keep looking up.